Hey, just doing a little video for Homework 3's Transformers. They are pretty straightforward after Homework 2's Power World video, but just going to do this real fast in case anyone has any issues. I'm going to run through it pretty quickly since it's so similar, so I'm just going to go ahead and start. I always start with, I think you always have to start with a bus, so I'm just going to go for it. I am making the generator bus right now, which is a 24.2 kilovolt slack bus. Tossing on the generator on here. This value doesn't matter a ton, I don't think. We, again, click in these values just to make sure we show everything. They will be changing, and we will need decimals. So right now is where we start kind of new stuff for making transformers or for adding transformers in your system. I'm going to have to add a total of 3 more buses. If we were doing just the transition line route, we would only need 1 more bus, the load bus. So I'm going to start off with our first transformer bus. It's a normal bus. You don't have to make anything special because it's a transformer bus. Oops, I pressed the wrong. I was making a look. Okay, here's our first bus, or rather, our first bus for the transformers. Changing this voltage to 138. That's what our transformer is stepping up to. Making sure it's in the slack bus. Sweet. I'm gonna put in our first transformer, stepping up from the 24.2 to 138. So we just come over here to network, transformer. It is gonna look exactly like transmission lines, but when you, and even these values, or this whatever input screen looks just like transmission lines. For this example, we don't have any like given length for a transformer, so we're not going to use this calculate impedance option. Everything is given PU per unit, so we're going to directly input those here in the per unit impedance parameters. So start with series resistance of 0.01, reactance 0.03, shunt charging shunt conductance of 0. I had missed a 0 the last time I made this, and it gave me some really wonky results. So make sure you get all these values correctly. We do have the MVA limit still. That's given as 800 kilovolt amps. So we have to make sure here to put 0.8 to convert it to megavolt amps. So next, we are going to add another bus. This is going to be what the transmission line connects between. So it goes from this 138 kilovolt bus to this next 138 kilovolt bus via transmission line. So it's already set to 138. Everything is what we want. So okay there. Perfect. And then we are going to set up a transmission line between the two. I'll go a little lower just so we can differentiate what we're connecting to. From bus 2 to bus 3, 138, 138, everything was good. Here, since we're doing a transition line, we're going to actually calculate impedances. We are given a length of 80, a resistance of 0.02 per mile, and a X value of 0.2 ohms per mile. That auto-populates over there. Okay. Sweet. And if we did it right, that should set us up with this little blue circle with amps. We are going to add one final bus. This is going to be our load bus. It's what our 138 is going to be stepping down to via the transformer. So this final bus up here is 13.2 kilovolt load bus. We again only need that here to make this work. Now, not sure why each of these have been made to be a different size, but we'll make it work. And then here, all we do is, again, put a transformer between them. So this guy, that. I don't know if I mentioned it on the last one, but we can see here we're going from 138 to 13.2. It's if you don't feel like double clicking on the bus to make sure that you're stepping down or up to the right values, this is a pretty quick way to see that. Our impedance parameters are all going to be the same here as our last transformer. So we're looking at 0.01, 0.03, I just realized I might have missed a negative sign in the last one, so I'm gonna have to go back and check on that. That all looks good. Yep, that looks good. I'm gonna double check this guy real fast. Yep, I also forgot to put the MVA limits. That is also 0.8 for the transmission line. Sorry about that. And then this guy making sure that I put the negative, which I did. Okay, awesome. So we now have our generator, a step up transformer, a transmission line, a step down transformer, and then finally we're going to put our two loads. Sorry if it's a little windy. I had to record this outside today. So I already did the calculations for the loads. We are given S value and then the power factor, which we can convert to beta. I have them calculated already, and if you don't know how to do that, you can see the last video. So the first one, we're looking at 0.301, and an M bar value of 0.30. Orientation to the right, that's just preferred for me. Okay. I'm also going to make sure that these values are shown, significant figures, just so I don't forget later. And then we have our final load. Here, you just click yes. This one is 0.20. Yeah, that all should be just the same as what we did on the last homework side. It shouldn't be anything too crazy. Once we do that, though, we are done. I'm going to full screen this now and finish up. Okay, so here's the full system. We have our generator, our system slack bus, step up transformer, transmission line, step down transformer, load bus with two loads. Once we're done with all that, we'll come over here to run mode, come to tools, and we're going to do solve power flow Newton. And this is what it gives us. I've confirmed this with a couple other people who all got the same values. Everything's red because it's over 100%. I think the point of these values, this simulation, was to kind of say that we were overloading our system. If you didn't get any of these or need any help, just ping me on Discord. All right, good luck.